The Java Collections framework has two interface hierarchies, the collection hierarchy and the map hierarchy. The collection interface specifies methods common to the list, queue, and set interfaces, like add, contains, isEmpty, set, size, and remove. All classes that implement the collection interface provide a one-parameter constructor that converts any type of collection to any other type of collection. The collection hierarchy includes a special kind of queue called a priority queue, which inserts higher priority elements closer to the head of the queue. A map uses a unique key, like an ID number, to provide rapid access to other, more complex objects and uses operations like put, get, and remove. Here's the collections framework. As you can see, there are lots of different collection interfaces and concrete classes. We're not going to go over any additional details on each of these. Just be aware that there's lots of different types. I would highly encourage you to look these up on your own for more familiarization because they will be useful in your continued programming career. I've mentioned interfaces a couple of times, and they're abstract classes, and we're going to cover them more in depth in Chapter 14. And here's the maps framework. So you might be wondering what exactly a map is. A map relates an object in a key set to another object that could be in another set, a list, or a queue. In other words, you can think of a map like a database with a unique key to look up information. Or a map is like a mathematical function. You provide an independent key and it returns a dependent value. We often talk about maps in the terms of key value pairs. For example, you could store a person object as a value and the key might be their social security number. Here's some common operations that we can perform on a map. We can add an entry, or we can get an entry, or we can remove an entry. Let's take a look at an interesting case. For this example, we're going to assume that we have a set of citizens. And each citizen is connected to a random set of friends, and that each friendship is mutual, meaning we have a bidirectional connection between them. We are then going to give one citizen a new message with a request to pass it on to his or her friends, asking them to do likewise, right? So we're going to tell this guy, and he or she is going to tell this person and this person right there, right? And we're going to continue on until all who can be reached have been informed. So they're going to tell all of their friends. Well, this person isn't really friends with anybody, but this guy up here's got 3 other friends. So he's going to tell friend 1, 2, and 3, right? So they're going to tell their friends, and those friends are going to tell their friends, and their friends are going to tell, and so on, and so on, and so on, until everybody that can be informed has been reached. So this red guy is the last person to be told. You know, he's like, man, I'm always the last one to know. All right, well, tough luck. So let's take a look at this visually before we look at the code. Here we'll put our first node in the sender queue and immediately move it to the informed citizen queue, right? And we're going to start with a different guy. So we're going to start with this guy right here. And we move him to the sender queue and immediately move him to the informed citizens because he's been told. Now for each of his friends, we are going to, or for any of his friends that have not yet been informed, we're going to add them to the sender queue. And remember how a queue works, it's first in, first out. So we add them to the sender queue. And we'll go through each of the first node's friends in the queue, moving them to the informed citizen queue and adding any of their friends that haven't been informed to the sender queue. Right? So we're going to take him and we're going to grab his friend, add him to the queue. We're going to take him, add his friends to the sender queue. And we're going to count this guy as informed and send his, well, he didn't have any friends. We're going to take this guy and add his friend to the sender queue. So now our next layer has been updated and all of their friends have been added to the sender queue. We'll move this guy to the informed queue and his friend to the sender queue. We'll move this one to the informed queue, but he doesn't have any friends that haven't been informed, so we'll proceed to the next person in the queue. And again, we'll move him to the informed and move his friends up. And if they have any friends, we'll move them to the sender queue. And we'll keep doing this until everybody has been notified. Make a little more room here. Okay, we'll move this guy to the informed. He's told his friend. Move this guy up. He's told his friend. Okay. And then finally, he gets to his friend first, and he gets added to the sender queue. And there you have it, our completed gossip simulation. So now that you've seen this, let's take a look at the scenario one more way, and then we'll dig into the code. So here we have a different network of friends, but this time we're just illustrating it as sets. So you can see here we have citizen 0 through citizen 15, and each of these are his or her friends. So he's friends with citizen 8, this one's friends with citizen 4, she's friends with citizen 1, right? And this would be the gossip network if we started with node 4. The dashed line indicates that a node is getting information from two different sources, but it's already been informed, right? So if we start with node 4 over here, we can see that they're friends with 1, 2, 5, and 10. So they tell 1, 2, 5, and 10, right? And you can see that they are one notification, one step from being first told. So that's what this delay is. It's the count of how many times has it gone through this telephone game, right? So then since 1 is the first one in the queue, it's going to tell 8, right? And then 5 is going to tell 11, and 10 is going to tell 6, but those are all being done in parallel, so they are all the second step of this network. Then 8 is going to tell 0, and 11 is going to tell 13, and 6 is going to tell 9, right? And so they all get told at the same time, but if we look, 0 and 9 are friends, but 0 isn't going to tell 9 because 9's already been informed. So 9 is not going to go below 0. And so this is how this network propagates through until everybody's told. Now poor 7, you can see them right there. They never get told because, well, they're kind of loners and they don't have any friends. So poor 7 doesn't get told any information about what's going on. All right, so let's take a look at this program here. Here we create this public class called community, and in it is a map of its citizens. And again, key value pair, we have an integer key and a citizen value. And then here's our constructor, and this is going to build our map that we're going to pass into it. So we're passing in a citizen quantity and a relation quantity. So what it's going to do is it's going to take in the number of citizens, and the relations is the number of friendships that exist. So if we pass in 20 people and 20 relations, that means that there's only going to be 20 connections between people. And then we're basically going to initialize our citizens with all of their ID numbers, and then we're going to randomly select 20 relationships among them if we pass in 20, or 40 if we pass in 40, right? Then we also have this get citizens method, which is going to return the map, of course, and it's an integer citizen, so you have to specify that we are returning this map, an object that implements a map interface that has an integer key and a citizen value, right? So in this case, we'll be returning a hash map because citizens is a hash map. And it says, and here you can see some additional information in the comments, like precondition, sender is part of an established network. Postcondition, return set includes all connected citizens. So this is basically saying that we are assuming that when you pass in a sender to this spread word method, that it is part of a network. It's not a standalone person. And so this spread word function is going to do exactly what we did in the diagrams. It's going to pick a person, and it's going to inform them, and then that person's going to tell all their friends, and their friends are going to get added to the sender queue, and then they're going to tell their friends, and it's going to process through all of that directly. So, and of course, here's the driver program that just sets up some additional information and prompts you for it, and then outputs the results, right? So let's go ahead and run this and see what it looks like real quick. All right, so inner citizen and relation quantities. Well, we've got 20 people and we got 40 relationships among them. And so here is what the community map looks like. Citizen 0 has 5 friends, citizen 1 has 3 friends, so on and so forth. So we are going to tell number 10 because he only has 1 friend. So let's tell him, let's get him out of the way first. When we execute it, you can see this is the process that the communication went through the network. 10 told 15 because 15 is 10's friend, right? Well, then 15 went and told 0, 2, 4, 7, 10, and 13. 0, 2, 4, 7, 13. So you can see all those are 2. And then all of those people are going to tell their people, and their people are going to tell their people, and their people are going to tell their people, and so on and so forth, right? So that's how it works. So pretty complicated. I highly recommend you take a look at this and kind of parse through it on your own and make sure that you understand it. It'll help you quite a bit. So say we got 25 people and 100 relationships, right? So now you can see that everybody's got a lot more friends, and if we just pick one at random, say 6, you can see that it only took 2 times, well 3 times to reach everybody, right? So what if we use a sparser network? What if we have well, let's see, let's try this. What happens if we use, what if we have 50 people and only 25 connections, right? Well, that's a lot of people without anybody. So we're going to tell 32, and those are the only people that found out. 32 told 42, and that's it. Because it's such a sparse network that it didn't get to everybody, right? So, yeah. Let's do one more, just for fun. We're going to do 50 people, and there's only going to be 100 connections. So everybody knows 2 people, right? And there you have it. Now, of course, it's random, so some people know a lot of people, and some people don't know a lot. But there's 100 total connections, and the average is going to be 2 people, right? 2 per person. So, well, that doesn't look like an average of 2 people. Well, it's bidirectional, so you're going to show up this twice. So there's going to be 200 items in here. All right. So there you have it. That's the program. It's pretty interesting if you actually take a look and walk through it and try to figure it out. It'll help you in future things as well. So that's it for this video and this week. We'll take a look at the summary next. All right, so to summarize, we talked about ArrayList and the ArrayList class and how to use it to store data. And we also talked about storing primitives. We also looked at how to perform for each loops using ArrayList and also how to use anonymous objects. Finally, or not finally, but then we moved on to linked lists, and we looked at the difference between linked lists and arrays and ArrayLists, and we also looked at how to measure the execution time. We also looked at queues and stacks as well, and how they're fundamental building blocks of a lot of different things in computer science and programming. So it's vital that you understand all of these different structures. And then finally, we looked at the Java collections frameworks, targeting specifically lists and maps. Some of this you're going to need to actually look up on your own and do some research and do some reading on the documents, because you're always going to have to do this throughout your career if you're going to be a programmer, is reading documentation and looking up things that you don't quite understand, and even playing around with them and using them to figure them out. So hopefully you enjoyed this week's lesson. I know it's a lot to cover and some pretty heady material. So watch the videos a couple times and make sure you bring your questions to class. Thanks.